In Chapter 10, we will start solving algebraic equations. In 10.1, we'll be looking at the addition property of equality. A solution of an equation is a number that makes the equation true when it replaces the variable. Equations that have exactly the same solution sets are equivalent equations. A linear equation is solved by using a series of steps to produce a simpler equivalent equation of the form x equals a number or a number equals x. Equations can be thought of in terms of a balance. Adding the same quantity to each side of a balance doesn't affect the balance. So, for example, if we have x minus 5 is equal to 2, that means that the quantity of x minus 5 and 2 both kind of weigh the same amount. So they keep the balance level. So if I were to add 5 to one side, make it heavier, then I add 5 to the other side, make it heavier by the same amount, and therefore my balance is still level. So the addition property of equality says that I can add or subtract the exact same amount to both sides of an equal sign and keep my equation balanced. We are going to use the concept of a balance when solving equations. So the first thing we're going to do is keep in mind that the equal sign is where my equation balances. So wherever I have an equal sign, I'm just going to draw a line straight down, and that's kind of where my equation is standing on its balance. Then I want to, in the end, my goal is to get x by itself, or the variable by itself. So I want to cancel everything else that's around the x. So on A, I have x minus 12 equals 9. So to cancel something, we're going to use the inverse operation. So if I have x minus 12, to cancel the minus 12, I'm going to add 12. Now keep in mind that this is a balance. So if I add 12 to the left side of the balance, making it heavier, I have to add 12 to the right side of the balance to make it heavier by the same amount so that it stays balanced. Okay, so minus 12 and plus 12 cancels. Those are zeros, they're opposite pairs. And I can bring down my x, and then 9 plus 12 is equal to 21. Okay, one of the cool things about solving equations is that you can always make sure you are doing it right, because we can always go back and check our work. So since my answer was x equals 21, I'm going to plug in 21 in place of x. So my original equation was x minus 12 equals 9. So in place of x, I'm going to write 21 minus 12 equals 9. So 21 minus 12 is 9. And so that means that I solved it correctly. Okay, so now let's look at B. And again, we're always going to start by drawing my balance line. Then I have x minus 25 equals negative 18. So to cancel my minus 25, I'm going to add 25 to both sides. So now my minus 25 and plus 25 cancel, and I can bring down my x, and now I have negative 18 plus 25. So look at our integer rules again. So negative 18 plus 25 means that if I have $25, I spend 18. So I'm going to look at all my pairs that I can cancel, and I can cancel 18 pairs, and I will have 7 left over on the positive side. So I have x is equal to 7. Okay, so now I want to go back and check that solution. So my original equation was x minus 25 equals negative 18. So I'm going to rewrite it as 7 minus 25 equals negative 18. Okay, so if I have 7 minus 25, that means 7 positives, 25 negatives, which is equivalent to saying I have $7 and I want to spend 25. Well, if I want to purchase something that's $25, I either put it on credit and owe money, or borrow from somebody and owe them money. And so how much do I owe? I owe $18. So negative 18 equals negative 18, which means that x equals 7 was the correct solution. Okay, on example 2, we're going to continue solving equations. The same method, so we'll start by drawing my balance line. X minus 3.7 equals negative 8.1, so we'll add 3.7 to both sides. Negative and positive cancels, bring down your x, and negative 8.1 and positive 3.7. So after I cancel out pairs, I can subtract, and I'm left with negative 4.4. Then we will go back and check that solution. So originally I have x minus 3.7 equals negative 8.1. So if I substitute negative 4.4 minus 3.7, okay, so negative 4.4, and then a minus 3.7 is also a negative. So in this case, I do not have opposite pairs to cancel out, so I need to add the 4.4 and the 3.7, which is negative 8.1, which means that my negative 4.4 was correct. On B, again, we'll start off by drawing our balance line. Then A minus 4.1, so the opposite is to add 4.1. That gives us A equals 10.4. And again, we will check that solution. So A minus 4.1 equals 6.3. Substitute 10.4 for A. Okay, so now I have 10.4 minus 4.1 is 6.3. In example 3, we're still solving equations, and we're going to solve them the same way. They're just written a little bit differently. On the first two examples, it was the longer expression on the left side with equal to a number on the right side. So you can solve it the same way as it's written, or you can switch it around if you prefer for your variable to be on the other side. So I'll show you both ways. So on A, we will go ahead and just solve it the way that it's written. So my goal is always to get the variable by itself. So this case, I want to get A by itself. So if it's A plus 2, to cancel the plus 2, I will subtract 2 from both sides. So 2 minus 2 cancels and gives me 0. I can bring down my A. And now negative 3 minus 2, that's a negative 3. Minus 2 is a negative. So there's nothing to cancel out. They're both negatives, so that would be a negative 5. Then going back to check, -3 equals -5 plus 2. So -5 plus 2. I have 2 pairs that would cancel, which would leave me with 3 pairs at the bottom. So -5 is correct. Okay, now if you're not comfortable working with the variable on the right side of the equation, you can flip it around. So basically we're going to take the -16 plus r and put that first, and the 22 and put it on the other side. So now I have -16 plus r equals 22. Same problem, just written the opposite way. Okay, so I have -16 plus r, so I need to cancel my 16. Well, if I put another -16, will -16 and -16 cancel each other out? No. -16 and plus 16, positive 16, will cancel out. So I'm going to add 16 to both sides. So whatever you do on the left side, you do the same thing on the right side. So since we added 16 to the left, we're going to add 16 to the right. So r is equal to 38. Again, we'll check our work. And I'm going to check it in the way that it was originally written, just to make sure I didn't make any mistakes when switching it around. So 22 equals -16 plus r. We're going to replace r with 38. So -16 plus 38, 16 is negative, 38 is positive. I would have 16 pairs to cancel out, which would leave me with 22 pairs. So 38 is correct. Example 4 will follow the same steps. The difference is, in this case, notice that there are variables on both sides of the equation. So we still start with our balance line, but this time I need to get rid of the variable from one side, because remember, your end goal is to have x equals a number, or m equals a number. Well, in this case, if I have an m on the left side and an m on the right side, I'm not going to get m equals a number if I have a variable on the other side as well. So we're going to cancel the variable from one side so that the variable is only on one side and the numbers on the other side. So in this case, let's think about this. If I subtracted 6m, I mean, it would work, but I'm leaving myself with nothing on that side. So the way you decide which way to cancel is you don't want to leave nothing on one side. Again, it will work. It's just extra steps that you don't have to go through. Alright, so I want to cancel my 5m. So 5m minus 5m is going to cancel. And then I'll bring down the 4 equals 6m minus 5m is 1m. So I have m by itself on one side and my number 4 on the other side. Okay, so let's check to make sure that 4 is the correct solution. 5m means 5 times m, so 5 times 4 plus 4 equals 6 times 4. So you have to plug in the solution every place where you see the variable. Alright, so 5 times 4 is 20. And 20 plus 4 is 24, which is the same thing as 6 times 4. So 4 is the correct solution. On B, we have the same situation, so 7 halves m plus 1 equals 9 halves m. So I have m's on both sides, so I need to cancel it from one side. So if this is 7 halves m, I'm going to put minus 7 halves m. So I want to cancel that, and I'm left with just 1. And 9 halves minus 7 halves, so there's already a common denominator. 9 minus 7 is 2 halves m, and 2 over 2 is equal to 1. Remember, if I write an m by itself, that's the same thing as 1m. Okay, so 1 is equal to 1m, or 1 is equal to m. And again, we will check our solution. So that's going to be 7 halves times 1 plus 1 equals 9 halves times 1. So multiplying by 1 keeps it the same. 7 halves plus 1 whole. If I wanted a common denominator, it would be 2. 1 times 2 is 2. And then 7 plus 2 is 9. So 1 is the correct solution. Okay, so notice that right here, I just changed 1 over 1 to 2 over 2. If I reduce 2 over 2, it gives me 1. So all I did was get a common denominator so that I would be able to add those together. C and D are looking at if you get a negative variable instead of a positive variable. Now, in this section, the book is just saying if negative x is 6, we can just find the opposite. In the next section, I'll show you mathematically why that works. Okay, so if negative x is equal to 6, then what is positive x? Well, if I take the opposite of one side, I have to take the opposite of the other side. So the opposite of negative x is x. So what is the opposite of 6? Negative 6. Same thing for D. If negative x is equal to negative 12, then I want to know the opposite of that solution. The opposite of negative x is x, and the opposite of negative 12 is positive 12. Okay, as we're working through example 5, notice that the steps that I'm doing are the same steps over and over and over again. So even though the equations are going to start getting longer, it's always the same concept of canceling a variable and then canceling everything around the variable, always using the opposite operation, always using the balance line, and always ending up with a variable on one side and a number on the other side. Okay, so my balance line is always on my equal sign. Step 1 is always, if I have variables on both sides of the equation, cancel it from 1. Now in this case, I have variables and numbers on both sides. So canceling a variable is not going to completely wipe out one side of the equation. Therefore, it doesn't matter which side I cancel my variable on. I can cancel it on whichever side I want. Okay, I personally tend to like my answers to be x equals something. So I like my variable on the left side. So if I want my variable to be on the left side, I'm going to cancel it from the right side. So I have a negative 2a. Well, how do I cancel a negative 2a? I cancel it with a positive. Now remember, we combine like terms. So if I'm canceling something with an a, I'm going to add it on the other side to its like term with the same variable, with the negative a. Okay, so my negative 2a plus 2a cancels, and I can bring down my 9. 10 does not line up with anything, so I'm going to bring down my 10. And then negative 1a plus 2a, so -1 and +2. I have $2, I spend 1, that gives me 1a left over. Remember, I do not have to write that 1 in there. Now I want a by itself, so the one I want to cancel is the one that's on the same side as the a. So I want to cancel my 10, so I have a +10, so if I subtract it, that's what will give me 0. So bring down your a. 9 minus 10, that's +9, -10. So 9 of those pairs would cancel, and I'm left with -1. Okay, so we'll check our work. So I have 10 minus -1. So make sure you bring down your operation symbols and then you plug in your number with its sign. So I have my minus sign from the problem and my negative sign from my solution equals -2 times -1 plus 9. So when I have a minus negative, that makes it a plus. So 10 plus 1 is 11. -2 times -1 is +2. Bring down my plus 9. 2 plus 9 is 11. Alright, so on B, we'll start off again with my balance line. And then I'll subtract a variable from one side, either side, it doesn't matter which one. So again, I'm going to choose to cancel from the right side and leave my x on the left side. Okay, so 5 minus 5 is 0, so I can bring down my 12. And then 6x minus 5x is 1x minus 8. And notice when I have 1x or 1a or 1m, I don't always write the 1. Okay, the variable by itself implies that there's one of those. Alright, so now I have x minus 8 equals 12. I need x by itself, so I need to cancel my minus 8. So to cancel the minus 8, I'll add 8 to both sides. And that leaves me with x equals 12 plus 8 is 20. And we will check. So that's going to be 6 times x, or 6 times 20, minus 8 equals 12 plus 5 times x, which is 5 times 20. So 6 times 20 is 120. 12 plus 5 times 20 is 100. So 120 minus 8, 112, and 12 plus 100 is also 112. Alright, example 6. My problems are starting to look a little bit longer, but all it is we're adding some simplifying steps. Other than simplifying, my solving steps are still exactly the same. So draw your balance line. The balance line really comes in helpful, especially when the equations get longer. That way it helps you remember to do the same operation on both sides of the line. It should never happen twice on the same side of the line. And you should never have opposites on the other side of the line. If you add to one side, you have to add to the other side. So the line just helps you not make careless errors that way. Alright, so looking at the left side, I need to simplify it by combining like terms. So I can combine 4x plus 2x to get 6x, and 6 minus 3 is a positive 3. Okay, on my right side of the equation, like terms, I have 9 minus 4, so 9 minus 4 is 5 plus my 5x. Alright, so now I have x's on both sides, so I'm going to cancel from one side. So I can subtract 5x. That cancels it from the right side, but keeps x on the left. So I'll bring down my 5, and then 6x minus 5x is 1x, bring down my plus 3. Now I want x by itself, so I can cancel my plus 3 by subtracting 3. And that leaves me with x equals 5 minus 3 is 2. Alright, so to check this, I have 4 times 2 plus 6 plus 2 times 2 minus 3 equals 9 plus 5 times 2 minus 4. Okay, so we're just going to solve this using order of operations. 4 times 2 is 8 plus 6 plus 2 times 2 is 4 minus 3. So 8 plus 6 is 14 plus 4 is 18, and 18 minus 3 is 15. And this is 9 plus 5 times 2 is 10. Then 9 plus 10 is 19, and 19 minus 4 is 15. Alright, so B, start off with your balance line. We're going to simplify both sides before we start solving. So step 1 is always simplify, as much as you can simplify. So I can combine like terms. 9r plus 4r is 13r. 6 minus 2 is positive 4. And on the right side, I have 9r plus 3r is 12r plus 4. Alright, so step 2, now that my left side is simplified and my right side is simplified, step 2 is to cancel a variable from one side. So minus 12r minus 12r. Bring down my 4. 13r minus 12r is 1r plus 4. Then my last step is to get the variable by itself. So I'll cancel my 4 by subtracting 4. So 4 minus 4 is 0. So r equals, and then on the other side I have 4 minus 4. So r equals 0. 0 is a number, and therefore it is an acceptable solution. Okay, so we'll check it. So it's going to be 9 times 0 plus 4 times 0 plus 6 minus 2 equals 9 times 0 plus 4 plus 3 times 0. 9 times 0 is 0. 4 times 0 is 0. 9 plus 0 is 0. Alright, so 0 plus 0, 0 plus 6 is 6 minus 2 is 4. And 0 plus 4 plus 0 is 4. Example 7. we are going to simplify the left side. So those parentheses give me a clue that to simplify, I will be using the distributive property. So I'll multiply the 4 to everything inside that set of parentheses that's multiplied to the 4. So 4 times r is 4r. 4 times 1 is 4. And then remember, anytime you have a minus sign in front of parentheses, that's the same thing as distributing a negative 1. So negative 1 times 3r is negative 3r, and negative 1 times 5 is negative 5. Okay, my left side still is not simplified. I can combine like terms now. So 4r minus 3r is 1r, and 4 minus 5 is negative 1. So then my last step is to get r by itself. So if that's r minus 1, to get rid of the minus 1, I can add 1. And I get r equals 2. Okay, so we'll check that. And to check, you always want to write it exactly the same way as the original problem. So it's going to be 2 plus 1 minus 3 times 2 plus 5. Okay, so order of operations says to do parentheses first. 2 plus 1 is 3. 3 times 2 is 6, plus 5 is 11. 4 times 3 is 12. And 12 minus 11 is 1. Okay, so B, we will start the same way. Draw your balance line. Distribute to get rid of parentheses. So negative 3 times m is negative 3m. Negative 3 times negative 4 is a positive 12. So remember that minus 4 is the same thing as a negative 4. Then we have another set of parentheses, so we'll distribute the 2. 2 times 5 is 10. Since it's a positive 10, it's going to be plus 10. And 2 times 2m is positive 4m. Okay, so we need to continue simplifying so we can combine like terms. Negative 3m plus 4m. Negative 3 and positive 4 is 1m. 12 plus 10 is 22. And my last step is to get m by itself. So if I have m plus 22, I can subtract 22 from both sides. So I get m equals 7. And like always, we'll check our solution. So it's going to be negative 3 times 7 minus 4 plus 2 times 5 plus 2 times 7 equals 29. So parentheses first, that'll be negative 3 times 7 minus 4 is 3, plus 2 times, now inside this parentheses I have to multiply 2 times 7 first and get 14, and 14 plus 5 is 19. Negative 3 times 3 is negative 9. 2 times 19 is 38. Negative 9 plus 38 so 38 positives, 9 negatives. I can cancel out 9 pairs, and that would leave me with 29 positives.